Another thing that I would want to add here is that if you look into this curve and along the y-axis here, you place a mirror there, right? You will notice that this black portion here, when you stand somewhere there and you look into this mirror, this thing that is going that side in the mirror, it will look like that. So this portion will look like that. Remember that our mirror will always place it along the vertical axis when you're checking even or odd. And there, if we are checking only even, we only place one mirror along the y-axis. But if we want to also check if the function is odd or even, for odd, we place the second mirror here. So odd has two mirrors, but even have only one mirror along the y-axis. Now that you have that, you can also see that if I were to stand somewhere here and look at this point here, at this portion of the curve going that way, you will notice that in this mirror, it will be that point there. Right. And if again, I look into this mirror here, which is the y-axis, and I stand somewhere there, this line will be that line, and this portion here will be that portion there. And this portion here, if I stand here, this line will be that line there, and this portion here will be that portion there. So basically, the second of x is actually having a mirror on that other side. So second of x is an even function. That's what I wanted to add. And also, when you look at the cosine of x, if I place a mirror along the y-axis, this portion here will be that portion there. And this portion here in this mirror, it will be that portion. So cosine of x is also an even function. Note that sine of x and cosecant of x are both odd functions, and cos and secant x are both even functions. Now that we have that, suppose now we plot cosine of x and sine of x on the same set of x's. I want to plot these two. Of course, I'm not gonna go into details. We tried to plot cos, and in the other video we plotted cosine of sine of x. So I'm just gonna plot them on the same set of x's here. So you'll find out that they will look like this, and a sine of x is the red curve there, and cosine of x is the blue curve there. And I also want to highlight the fact that if we were to say that we are moving this curve, or we're shifting it a couple of units forward, not just a couple of units forward. This one was 0, x was 0 here, and then at this point here, x was pi over 2. So if you shift, this is cos, if you shift to cosine of x such that we had, let's say, f of x, it was cosine of x, and then now we say f of x is equal to cosine of x, but you shift it 2 units to the right, so we subtract, so it's going to be minus pi over 2. So if we shift this function pi over 2 units forward, this will be the same as sine of x. That's what we're seeing, because this point will be here, this point will be there, this point will be there, and this point will be there, and this point will be there, and so forth. So shifting a cosine function, you get a sine function as long as you shift it by this couple of units. That's what is important. And secondly, you can see that this one is an odd function, sine is an odd function, and cosine of x is an even function, which means that you can be given a function such that if you can shift it a couple of units, you can also change its symmetry by just shifting it a couple of units. That's also what is important. But the main reason I drew these two is because I know that if I have f of x is equal to tan of x. Tan of x is the same as sine of x divided by cosine of x. That's what we know. And also another thing in this particular function here, I want us to take note that whenever cosine of x is equal to 0, I'm going to use a different color here. I want a strong one. If we use green, I don't think that will be a problem. If cosine of x is 0, where is cosine of x? Cosine of x is blue. So if cosine of x is 0 at this point, and that point, and at that point, and at that point, this whole function is not defined, which means tan of x is not defined. So what we will do here, we're gonna place a vertical line there just to show that it is not defined, and then a vertical line there because it is not defined, a vertical line there. This is bad. I want to be somewhere there. Trying to make sure that it is not that bad, and a vertical line somewhere there. This one is too bad. A vertical line somewhere there, and a vertical line there. Yes, it's not that good, but it's not that bad also. And yeah, we're looking at cosine there, and then I'm gonna make these dotted lines because the function is just not defined at those points. Yeah, I've drawn these vertical lines there. Now, what I want us to look at these points, these functions are not defined, but I also wanted you to note that when this function, when these two curves meet, which means they are equal at those points, taking two things that are equal and you dividing them, you're always gonna get a 1. So somewhere there, this function has to go there, and at these points here, when they meet, we're supposed to have a 1 there, and then when they meet, what's this? This one, they meet there, they are equal, and this one, they meet there, we're supposed to get a 1 there because they meet there. And also at that point here they meet, and also at that point there they're supposed to have a 1. So whatever this tin function is, at these points this function has to pass through that point. And now let's look into this. If a sine of x is equal to 0, note that when sine of x is equal to 0, cosine of x is not equal to 0. Matter of fact, it is either 1 or minus 1. So if sine of x is equal to 0, this whole thing will be equal to 0 because the numerator is equal to 0. So sine of x is the red one. So whenever sine of x is equal to 0, this curve is equal to 0. So this point here is supposed to pass through that point, and then it goes this way as sine of x is 0. So it has to pass through that point, and then it has to pass through that point, and it has to pass through that point, and it has to pass through that point. Right. And now, if we talked about this, and we talked about when sine of x is equal to 0, that this curve is going to give us a 0. Now that we have done that, also, if let's say you pick a point here whereby this function, you can see that at some point here this is exactly between 1 and 0, and this side exactly between 1 and 0 and -1. So whenever you look into this point and that point, you can see that those 2 points are equal, but one of them is negative. So sine and cos, they are having the same value except that one is negative. So basically at this point here, if you take that point and then you divide them, you will get a -1 here. So this function is supposed to pass at -1, and then of course we go all the way. This function are equal to have a 1, and then here of course we get a -1, and then of course here we get a -1, and then here we get a -1, and here we get a 0. Now, how does this function of ours is actually working? Because all we just have to do, we want to join the points and actually see what is basically happening here. If let's say here, remember that I pick a point somewhere here that is close to 0, and I pick a point here that is close to 1. Let me say 0.99, and then I divide that by a point that is, remember that cos is in the denominator, that is very close to 0. I'm going to say 0.01. What will I get? I get a very big number. So if I pick a point somewhere there, I should get something that is so big somewhere there. Right. And then if I do the same thing, remember this point, and if I pick a point here, and this point here, no, I have this point, I'm looking at the blue here, this point and this point here, I will get something that is somewhere there, so big, so big, so big. So basically what this thing is saying, because this curve here, when we have sine, it's gonna be 0 like this. So we're supposed to have a nice, what am I doing here? How is this? Move that. So this one is supposed to move nicely like this. Right. And when you look into this part here, you can see this curve is gonna pass through here. It has to pass through here and go all the way like this. And then also when it comes here, it has to pass through here, and then it goes all the way like this. And also this portion here, it goes all the way like this. And then what am I doing here? It goes like all the way like this, and then it goes all the way like that. And then you do the same thing for all these other points, going like this, and then it goes all the way like this. Of course, my graph is not really drawn to scale, and also here it's gonna go all the way pass through this point and go to 0, and then it comes down like this. Of course, now because it's dirty, we don't really see what is basically happening here. But if I can erase these curves, because we used them to plot this curve, I can just see. I'm gonna remove it like this, try and make sure that at least it looks cleaner, so that we can see how it looks like. I'm gonna try and clean this up and see. So after cleaning it like this, you can clearly see now that's why tan of x look like this. And of course, if you are looking at the domain of tan of x, you will find out that the domain of tan of x is an element of real numbers such that x cannot be equal to these values here when sine is equal to 0. I mean when cos is equal to 0, which is pi over pi over 2. And if you look at this side also, we don't want it to be minus pi, so we don't want plus or minus pi, and we also don't want a 3 pi plus or minus 3 pi over 2 and so forth. So that's the domain. And of course the range, if you look at this small portion here, it takes all the possible outputs. So the range of tan of x, you can just say y is an element of real numbers. And of course, when you're talking about this, you will find out that as you go this way, it's gonna go all the way up. But if you jump this point here, you will find out that actually this function starts to repeat this thing at this point here. Look at this point here. This will be different. Let's say if you start to go this way and then we jump a little bit, you can see the function is increasing. Once it starts to arrive at minus pi, you can see that it starts to do the same thing it was doing from minus pi up until there. So it keeps repeating. And if you look at this point here, it was going all the way up, and then once you pass this point, it starts to repeat the same thing here, which means that this function is periodic. So it is periodic because after a certain interval, it keeps repeating what it was doing. And if you start at 0 and then you go all the way up, you can see that from 0, starting at this point, this is not the same as what it was doing there, but once you arrive at this point, start to repeat what it was doing there. So from 0 up to pi, this function here is performing is doing something that is different throughout that interval. But once it passes that, it starts to do the same thing it was doing. So the period of this tan function, you can say that it is from 0 up to 2 pi, or you can just say it is, up to pi, it is just pi. After pi, it starts repeating the same thing. And even here, if you want to find out this interval from here to here, you can just say minus pi, which is this highest point here, minus 2 pi, which is the same as minus pi plus 2 pi, which is just pi. So the period of this is just a pi for this tan function here. And also another thing to note here is very simple, that if I were to place here a mirror, let me say now I am placing a mirror here. This is my first mirror. If I stand here, this point here will be that point there. And now, how should this portion look like? So it was supposed to pass like it was supposed to go like in the dotted lines, and then it meets there, and then it goes all the way like this. So this is supposed to be like that. Now that we have this nice curve here, you will notice that the first mirror is just giving us this vibe here that this is not an even function. So this portion here is not an even function, right? So this is not an even function because when I'm placing a mirror, this is not part of the curve. But if I place now a second mirror here, I have a second mirror somewhere there. And then you will notice that by placing a second mirror, this portion here, a mirror somewhere at the x-axis, and I stand this side, this will be that. In other words, this portion here, the red portion, will be this portion. And if I look into this one, it will become that. Right. Now, what does this simply means? It simply means that a tan function is actually an odd function. So it is an odd function. And now, looking into this again, of course, let me look into this. Because here everything is kind of straightforward. I did make yeah, I think that's how this thing looks like. Place a mirror, you see that thing here, and it's always clear if you have your right graph, because if this graph is not right, you might end up having a wrong answer. But this is how this looks like. So this is an odd function. Now, what if we were to find out cot of x? Now, when it comes to cot of x, things are going to be a little bit different here. Cot of x at this point here, because cot of x is the same as 1 over tan of x, right? Cot of x at this point is not going to be defined. So it's not going to be defined at all. But when tan of x is equal to 1, tan of x is equal to 1, maybe somewhere there. Where is our 1? Suppose 1 is somewhere at that point. These functions are supposed to be equal. So at 0, this is undefined. And we're here, at this point here, let me use a different color here. And at this point here, when tan of x is equal to 0, cot is not defined. And also at this point here, it is not defined. But whenever this is equal to 1, these functions are equal. Whenever this is minus 1, these functions are equal. Whenever this is minus 1, this is equal. And whenever we have a 1, these functions are equal, and so forth. So what does this simply mean? Of course, here the function is not defined there, and also at that point there, the function is not defined. So basically, you will end up having something of this sort here. It's gonna go like this. Go like this. All the way like this. And also this side here is gonna go all the way. Where's this? This one is not supposed to touch there, and then it's gonna meet there and go all the way until it arrives there, and then it goes down. And then here you will notice that it goes like this because it's not supposed to touch, and then it goes all the way. This is not supposed to touch there, all the way like this. What am I doing now? Where is tan of x equal to 0 here? It is this point and this point. So let me fix this. So it's gonna go all the way. Here they're supposed to be equal, and then it goes all the way until we go somewhere like this. And then of course here it's not supposed to touch, so it's supposed to go all the way, but they're supposed to meet there and then go down. It's not supposed to touch this, or not supposed to touch that, so it's supposed to go all the way and then gets there. So that's what's supposed to happen here. But again, if I place a mirror here along the y-axis, let me see here. I place a mirror along the y-axis. What's gonna happen here? What will happen is that this curve here, this tan is just, if I place a mirror here, I mean this orange here, it was supposed to come like this. It was supposed to come a little bit like this, right? And then after that, if I place let me look for a clean thing here, because this one is not clean at all, and it's gonna be much more confusing. But this is how you end up plotting the tan function on the, the cot function on the same set of x's as the tan function. Well, let me look for this 16. 16, looking for 12, and then 12, edit. Yeah. So if we look carefully into this, what is supposed to happen? I wanted to take a look into this. Suppose I place a mirror along the y-axis here. this point here, this one is a tan function, and this one here is the chord. So if you look into this chord here, if I place a mirror here, it was supposed to go all the way, like this, go all the way. Well, let me do something like this. New window, anoint. What's this thing now? Recent 12 edit open. Or this one here, I wanted to open this. So if you look into this, if I place a mirror there, I have my mirror there along the y-axis, and of course this one is supposed to look like this. It's supposed to look like this all the way, something like this, right? It's supposed to look like that. But now, because when you are here, you stand here, you'll find out this line is going to be that line there, and this is going to be that curve there. But this curve was not part of this. But since it was not part of this, and I place a mirror along a second mirror here along the y-axis, along the x-axis, this one here will become this thing here. It will come this side, and this side here will become that side there. So actually, the tan of x is an odd function, and also the chord of x is an odd function. So both these two are actually odd functions when you start to analyze them, but now it's just a lot. And also, if you look into this piece is the same as that. So if I were to place a mirror there, this side will be that, and also this will be that. So this is a reflection along the y-axis. So it is a reflection along this line here, which is just pi over 4. So this is a reflection of that along the same thing. That's what I wanted to explain when it comes to plotting this. It's a little bit complicated, a little bit challenging, but this is how you end up plotting these nice curves here.